converted into a product is called substrate. What is that called? Substrate. Hence, if you carefully observe enzymes, what are they? Enzymes and proteins, okay, with three-dimensional structures, including an active site, or converts a substrate, okay, into a product called P. Okay, substrate is indicated by S, product is indicated by P. So symbolically this can be depicted as S to P, substrate to product. So what do you mean by that? From the substrate called S, product P generally comes out. Okay. Finally, it is now understood that substrate has to bind with specific enzyme, then only the product will come out at the active site. Okay. Now the substrate has different fuse towards the active site. Now there is thus an obligatory formation of ES complex. Here E stands for enzyme. For binding the enzyme with the substrate, there is an active site. This complex formation is transient phenomena, and during the state where substrate is bound to the enzyme active site, a new structure, especially this new structure of the substrate called transition or state structure is formed. This transition state very soon after the expected bond, if it is breaks, what will happen? It is completed, the product is released outside. So when the bond is broken or breaks. Okay. This, in other words, the structure of the substrates so gets separated into simple structures called monomers or simple transformation products. Now here you can see the transition site. Let us take the graph. On one axis I am taking progress of reaction. Progress of reaction I am taking here, and whereas protein energy I am taking here. Okay, and you can see here action of or activation of the energy here, and here you can see, okay, here onwards you can see activation of energy with the enzymes. So here this is an activation of energy without enzymes. Activation, here you can see this indicates activation energy with the enzymes. Okay, here you can see substrate S will be mentioned. Okay, under protein energy, etc. Okay, after this you can see transition state structure. There could be many more altered structural states between the stable substrate and the product. This implicits in this statement fact that all other structural states, whatever there, are unstable. Stability is something related to the energy status. Stability is nothing but it is related to the energy status of the molecule. Energy status of the molecule, right? Now, hence, when we look at the pictorially, or when we look at the picture, I will show you the picture on the graph here, and the y-axis represents, okay, potential energy. Y-axis represents potential energy. X-axis represents a substrate or progression of the structural transformation of the state. Okay, states through transition state. What is that? Transition state. Understood, everyone? Finally, if you carefully observe, you will notice two things. The energy level differences between S and P. If P is the product or lower level than the S, the reaction is basically here exothermic. If it is lower than exothermic, one need not to supply energy by heating in order to the byproduct to the product, not to the byproduct. However, whether it is an exothermic or endothermic reaction, if you take the exothermic spontaneous reaction, exothermic reactions are also known as spontaneous reactions, or endothermic reactions, if you carefully observe, they are also energy requiring reactions. They require a lot of energy for the process of reaction. So the S has to be go through much higher energy levels in the transition state. I have shown you in the diagram also. The difference in an average energy content, S form, okay, of this transition state is called activation energy. Okay. After this, enzymes eventually bring down this energy. Okay. Enzymes whatever activating in that substrate, okay, that energy whatever present there, making that energy comes to the normal level or brings down to the normal level more easily. Okay. What will be the nature of enzymes that we will discuss in